My name is Barbara Murphy. I'm the Vice President of Marketing with WekaIO. And today I'm going to take you through the agenda and that we're going to present. So first of all, I'm going to give you a company update. We had the honor of presenting here last year. It was our first year. We had just come out of stealth mode 6 months before. The one thing I want to thank Storage Field Day, and I say to all of you, is this is an asset that lives for a long time. I cannot tell you the number of customers that have come to us and actually found out about us and learned about us through this forum. So we're really delighted to actually have the opportunity to participate again. And your questions actually really help in terms of the dialogue and allowing us to have a free-form conversation. So we look forward to that. So I will present a refresh on what we do for those of you that we have not presented it before. I will focus as well on where the company has actually channeled its energies. And I'll talk a little bit about our bodacious performance claims, as you will see later. After that, Shimon Ben David, our Senior Director of Sales Engineering, is going to come up and do a product demonstration, because all of these slides are great, but the meat comes when you actually see the real product. Then we're going to have Andy Watson, our CTO, come and do a chalk talk on the architecture, and we call it a day in the life of a WekaIO. And last but not least, like all great shows that you put on, you keep the best performer for last. Liran Zivel is going to come up and talk about delighting and winning our customers, and in particular, the use cases where we have excelled. So with that, I'd like to do a quick introduction of WekaIO. WekaIO Matrix is the fastest, most scalable parallel file system for AI and technical compute workloads to ensure your applications never have to wait for data. We have been awarded significant number of awards over the last year for the product. The one that I'm most proud of recently is the AI Iconics Award for the best innovation in deep learning. This is specific to the work we've done around that particular use case and vertical. If you look at our partner ecosystem, a year ago, this was a relatively small slide. Today, we have technology alliances with a broad spectrum of the ecosystem that we care about. Things I would point out here are, for example, because of the nature of our product and we integrate tightly with object storage, we have relationships with Western Digital, with Scality and Cloudian. And we also have relationships with the applications that run on top of us. So for example, KX Systems, a time series ticker analysis is a very important piece of the ecosystem from our customers in terms of what they're using. We have great relationships with them as well. Obviously, key to machine learning is NVIDIA, who we work with very closely to ensure that our product is optimized for their DGX platforms. We've also, over the last year, did a tremendous amount of work in building out our reseller channel. As you will find out, we are a software-only product. We do not sell hardware. And essential to our go-to-market strategy is having a very tight relationship with the reseller partners who really build the ultimate solution for our customers. We have relationships with Amazon Web Services, who we are on their marketplace today, so anybody can use our product at any time and find out what it really looks like, and we don't even have to get involved in that. All the way to HPE, who is actually OEMing our software and integrating it into their Apollo platforms, as well as some other platforms inside the company. And then we have a variety of resellers such as Dasher and Nefos. So we have UK. We've actually expanded outside of the US in the last year and now have both a European presence on the ground, both in the UK and now Germany, as well as having a US presence. So a very, very big piece of our growth has been developing this reseller channel. And to the point where last quarter, I actually asked our reseller sales manager, 91% of our sales came through resellers. So we pretty much consider this the main go-to-market strategy. And obviously next year, I'm sure that you won't be able to even read the logos.
Cloudian and Scality as technical alliances, I mean, with WekaIO being like a front end and them being like a tier, is that how?
Effectively, yes. And when I get to the product, I think that's a great segue actually to my next slide. So what do we do? We are, first of all, we're a piece of software. WekaIO Matrix is a software-defined storage platform. We run on anything from bare metal all the way through VMs, or you can run us in containers. And last but not least, what's really important, we have both an on-premises component or a cloud component. So where you choose to run this piece of software is really about how you're running your business. If you've gone to the cloud, as many have, we're there for you. And if you're on premises, we have that too. In fact, if you want to have a hybrid of both models, we have customers doing that as well. We are a fully coherent POSIX file system, and our claim is that we're faster than local storage. And this isn't just a claim. This is actually something that we demonstrate day in, day out to our customers when we go into a POC environment. The reason this is really important is the use cases that we're targeting. Very often the use case currently with those customers is to use their NAS share as literally a data lake, copy data into their local drive, and run the applications on their local server. That has a tremendous amount of overhead in wall clock time, and particularly when you're talking about use cases like machine learning, where ultimately for autonomous vehicle drivers, the race is to the guy who solves it first. Every minute counts. So what we're doing is solving that problem of having to take data from a NAS share, copy it, and then run it local. We will run it faster as a share than you can possibly get with that model. The other thing about the product is it's a fully resilient product. We have our own distributed coding schema. It looks a lot like you think of erasure coding, but we don't have the performance penalty that you typically see with erasure coding. The other nice thing about the product is we are a scale-out file system. In fact, we're a massively scale-out file system. The more you scale out, the more resilient everything becomes because you actually have more compute resources helping in the rebuild during something like a drive failure. So bigger is actually better for us, which often is hard for our customers to get their head around, but actually think of it this way, more resources are actually participating in that rebuild. We're also distributing the data across many more resources, so the probability of 2 failures, for example, goes down dramatically. Last but not least, like you would expect in any high-performance system, we have full end-to-end data protection. The way you deploy us, you can deploy us as a converged appliance, which means you can run both the services of your applications as well as storage on the same box, or you can run us as a dedicated appliance, which is more the traditional storage model that you would expect from somebody like a NetApp or an EMC. Either one for us doesn't matter because our software is fundamentally a service. It runs in a container, and where you put that container is a function of how you want to run your environment. We can run on-premises or in the cloud, or we can give you a hybrid model for both. And we also run on the standard networks that you'll find within the enterprise and also high performance, both InfiniBand and Ethernet. We love 100 gig Ethernet or InfiniBand EDR because we love to fill up big pipes, but you can start as little as 10 gigabit and scale all the way up to your biggest pipe. The product is literally packed to the gills with a lot of the enterprise features that customers are expecting today. So things like NFS, SMB. I talked about our POSIX client. That's how you get the great performance. But a lot of the accessibility of the data is over your more traditional protocols like SMB and NFS, which have to have things like your directory services to be able to manage those users. Already, all of that exists within the product. We have things like network high availability, for those that really care about making sure their clients always have access to the storage, as well as things like encryption and tiering. And this gets to raise...
Do you expose S3 in the front end?
We can expose S3 to the front end, SMB, NFS, or our POSIX client, all of them to a single data store. So this is a very important point. A lot of the vendors have...
S3 is native.
We're using gateway services to get to S3, but from the perspective of the user, it's seamless. So we have a key piece, though, is that the data accessibility is a single data share. So you can come in over one protocol and go out over another protocol. It is not separate islands of storage within storage services, which a lot of the vendors have actually implemented. In terms of the model, we have a very flexible deployment model, as I mentioned. So this is kind of a typical environment you would see, a combination of maybe some GPU servers, some more classic high-performance servers, as well as your traditional protocols. We also have a very, very key piece of our architecture is a view that, especially for large-scale environments, most of your data is sitting in an idle state, but needs access from the main applications at some point in time. So we have the ability to integrate seamlessly to object storage. This gives you a cost dynamic that allows you to be able to run object storage at massive scale, while you still get the high performance of flash. And we've seen over our customers over the last year, we actually have a very good view of what this model typically looks like. It's generally in the region of about 20% of your data sits on that flash tier, and then the remainder of your data can sit in your object tier. And seamlessly in the background, we manage the data ingest to the flash tier as your application is calling for it. So this isn't a data migration tool. This is really presenting a single namespace and being able to scale out that namespace in a massive way and get the benefits of object store like geo-distribution. So for example, we have one customer who has a DR site on a second location where we can do things like take a snapshot of the entire system and file system, push that to the object store. It gets geo-replicated to a second location where they have a DR system ready and waiting in the event of a major failure on their first site. They can now rehydrate the file system based on that snapshot to that new location and continue operations. So what we're looking at and what we're delivering is effectively continuous operation with minimum downtime in the event of a major disaster. Things like object storage give you that ability, and we've taken an approach of taking a very modern approach of looking at how you treat more traditional DR and coming up with a way that allows you to have the resiliency, but the scalability as well of object store.
Also cloud DR.
And of course, the cloud, that is another piece, one of
Barbara,
that aspect.
will you be going into looking at how the S3 piece is integrated? And I'll give you an example of where I think I'd be interested to understand. You say that it's a single namespace, and therefore we're expecting that the data is spread between the flash and the object store. And you also said about geolocation. So if I move that data to another location geographically or accessing it from another location, how do things like locking, file system, ACLs, and all of those sort of things get exposed in another geolocation if I'm spreading the data across?
So I want to be careful. We're not a federated file system.
Right.
I'm talking about a DR. So in the event of disaster, you're effectively rehydrating the original file system that you have on premises,
So it's not
which already...
tiering. There are two features. One is tiering. So
Yes.
part of the file system is in the front end, flash, memory, and stuff, and part in the back end. And one is a consistent snapshot functionality
Correct.
that gives you the ability to rehydrate the file system.
Exactly. And the object storage gives you, because the object storage has been building this for a long time, we're leveraging the features that already exist within their extremely resilient systems to be able to provide a very nice, graceful way to get back in production with such things as like a major catastrophic failure at one site. So the other example I'm showing you here is our converge mode, which is where we're running both the services of the storage and compute on a single environment. We find that this is something that our cloud customers actually like a lot, because they spin up something like an i3 instance that has a lot of compute resources available, a lot of memory available, and storage, and they can clusterize that and create a very nice shared file system with lots of available compute resources to run your applications as well. So that's kind of a view of it, and obviously both models can run either on premises or the cloud. We also have a customer like TuSimple who can actually have the ability to use their on-premises snapshot, push that to the cloud, and now have the ability to be able to do on-demand compute in the cloud when they need extra compute resources. And that's actually another thing that's very important. Our customers, when we're actually talking to our customers now, the ability to have cloud out is proving to be one of the key differentiators that we're finding about the product, because even though some of them today are not doing anything in the cloud, everybody wants the ability to be able to move to the cloud or be able to leverage the cloud, particularly for their compute agility as they move forward.
We are enabling our customers to keep the bulk of their work on premises, and then when they need to burst, to have a bit more work that is independent, they can do it on the cloud. So we basically enable the elasticity that the public cloud provides to customers that want to keep most of their workloads on premises. So we won't let you lock the same file on premises and in the cloud for the same application, but in many times what happens, the users can chunk away a complete set of work that needs to be done. They push that work to the cloud. That work is done there. They take another snapshot, push it to the same bucket, and then they access that snapshot from the on-premises system. And to their on-premises users, it looks as if the work happened locally, but magically, they were actually able to leverage cloud, hopefully for them, spot instances.
Thank you, Liren. So here's the use cases we've focused on.
Sorry, there is a question coming from Twitter, and this guy asks if there is a replication option without using additional capacity on the object store.
So currently, we do not have the ability to do a replication inside the product.
Okay.
The other thing is focusing.
So I guess the question then becomes, how do you deal with the eventual consistency versus, regular consistency? That your file system, right, has to have normal consistency, but the S3 is obviously eventually consistent.
We have spent a lot of our IP on solving that problem.
Okay. And you don't want to talk about it?
No.
All right.
Also,
good.
they do not do the tiering at the file level, right? But at the block level. So you move very small objects.
Well, it's going to be.
To the
So we
cloud,
actually, it's interesting because what we do with are the files that come into the flash tier, everything's dealt with at 4K block level. And then when we tier out, we're effectively chunking large files into chunks, 1 meg chunks. So those 1 meg chunks live as objects in the object tier. And actually that has some very nice features in terms of when we're actually in production, because if you have something like a large media file or a large image file, and you're modifying a piece of that file, we bring back the chunks of the file that you're working with, not necessarily having to rehydrate an entire large file back into the flash tier. So at any point in time, some of your data can actually be on the flash tier and the object tier in the same file. So it has that. So that's how we treat the object tier. The backend is effectively a parallel file system to an object, like almost like a traditional Lustre or GPFS type file system, and the front end is a parallel file system with flash capability.
And how are you managing the metadata profile? Is that sitting in multiple?
So the metadata is distributed evenly across all of the nodes in the cluster, which again, as you scale out the cluster, you scale out the metadata, so the performance continues scaling as you add more nodes. So the traditional concept of metadata services with the storage separate from that, we've really broken that, and metadata and data are spread evenly across all of the nodes in the cluster.
You mentioned 4K blocks, right?
Yes.
And a lot of those parallel file system usually has much larger blocks. Why 4K? Is there a reason behind it?
It's the granularity level that SSD flash likes to work at as well. So we're working effectively at the best layer that works with the flash tier. And you do bring up a good point. The parallel file systems the traditional ones were designed to work really well for spinning disk. As we've moved to a flash world, that's a real challenge actually, is getting a very fine granularity, especially around data, small files and metadata, which we do extremely well in the file system. And I will show you some numbers on that later.
Does it create a few issues when you deal with object storage in the backend? Because if you move 4K files to the object store, you get a lot of writes.
So we chunk 1 meg chunks to the object store.
Gotcha.
Yes.
Okay. Very
And actually that is something as well we're actually working right now as well with some of the object vendors to actually optimize that so that it'll fit really well with their specific object tiers as well. We're focused on performance use cases. And obviously classic would be machine learning and AI. Real-time analytics. Also, genomics is a very big vertical for us. And the third big one that we have a lot of success with is financials, and that's again gets down to the fact that they have tons and tons of very tiny files and a lot of metadata that needs to be handled. This is a view actually of our customer installed base. You can see that our number one vertical is machine learning by a long shot, over 60%. But you've got to understand the machine learning actually is a horizontal use case. It's not a vertical. So the use cases can be all the way from manufacturing. There's some genomics. There's some financials in there. A lot of autonomous vehicle where we really have a very nice marrying up of both our very large data lake object storage with the flash tier. For example, customers in that space pulling in 8 terabytes per day per car, it doesn't take them very long to have an awful lot of scalability requirements. But they need performance and they need a file system to be able to actually talk to their applications. And so our combination with the object store is actually a fantastic solution for that. We also have some great customers in the genomic space, in more traditional genomic space, where they've frankly reached the limits of scale on their isolon systems and are looking to get much more scalable storage and frankly a lot higher performance than they can get today.
On the genomics market, what is the usual size of the typical cluster you would see in this kind of...
In genomics?
Yeah.
Multi-petabytes. A small one would be 5 petabytes. We've just had an installation, which I hope we can talk about in the next couple of months, where the initial installation will be 25 petabytes, growing to 150 petabytes over the next couple of years.
And you're running a specific file system on that? You're running something like, BGFS or...
So we're running WekaIO file system. Okay. We actually would compete potentially with the BGFS with just a much higher performance file system. So next thing I want to quickly talk about is performance. So we have a very bodacious claim. We claim we're the world's fastest parallel file system. A lot of vendors claim they're the world's fastest file system. So we always believe in using numbers to prove our statement. So whatever we say, we want to back it with real numbers. We've actually this year reached number 1 in SPEC, and very briefly, I'll talk about it later, and IO 500. And the IO 500, for those of you that don't know it, SPEC is more traditional enterprise file workloads, and IO 500 is specific to the high-performance compute market, where we also reach number 1 position. So start with SPEC. These are the results that we published in February for SPEC. And the way SPEC works is they work it on the basis of your application. So they have database, EDA, they have many others that I'll show you. And they say, for this workload, we want to see how well your system runs. You can see on database the 3 vendors that have submitted, DDN, Gridscaler, which is the IBM GPFS system, Oracle, and WekaIO. Now, you may notice something about the numbers here. It just so happens that our 4,500 is exactly double what you got for, I think it's 44 is the exact number. So we're double what the previous number 1 was. And this is just really for us to put a benchmark in and continue showing the performance of our system. The way that SPEC works is they have 2 dimensions. They have your number of builds that you do, or number of processes you do, in our case 4,400, and also the overall response time. And you can see for us it was overall response time of 290 microseconds, which is fantastic. If we were a block storage device, this would be fantastic. It's a file system. But there's really a dimension that this doesn't talk to, and that is time. What that overall response time is telling you is that we're completing the tests in 290 microsecond overall response time versus 3.86 milliseconds. It amounts to wall clock time on your server resources that are running your applications. So not alone are we actually doubling the number of workloads we can do on our system, which frankly, if you add more storage, you can always do a lot more. What we're really showing here is we're getting a lot more out of your compute clients that are very expensive because of how fast we're doing the actual benchmark. So that's the dimension I want to highlight, that it doesn't necessarily show. It's all about we're maximizing the compute resource utilization by virtue of the way we're running a low latency system.
There is a third dimension, which is dollar per gigabyte.
And dollar per gigabyte, exactly. Which I'll show that later. So, but there's more. This is VDA, which, by the way, is video streaming. You can see it's a 90% write-intensive application. Again, IBM Spectrum Scale, Cisco, Oracle, DDN, WekaIO. We beat the benchmark again on this one. Next one is VDI. The two vendors that have done this are DDN and WekaIO. Again, insanely low, sub 500 microsecond latency on VDI. EDA, another one, which is testing classic EDA builds, software builds. DDN, Gridscaler, Oracle, and WekaIO. Anybody notice anybody missing? EDA is a very, very specific niche for a very specific appliance vendor. Nobody knows? Well, no, it's network appliance. This is their major market. But for some reason, they haven't actually done a benchmark. Again, this is 50% stats.
I don't think like software build would be more of a NetApp market that they would go after. I mean,
they're actually #1 vendor for EDA as well.
Okay. I would say is one thing I would caution here that SPEC SFS uses ORT, which is our operational response time, overall response time, and you're actually plotting all the response times across all the workloads. So some of them would have a lower ORT, but they actually don't accomplish as much work as you would. And specifically the database ones, you're going off to 4,000 databases or something like that. The rest of these guys aren't doing well as well, but so.
So this is the last test, which is the software build. And for a brief moment in time, in February, we could claim we were #1 position. But our friends at NetApp actually had ready in the back pocket a second benchmark. So they are today ahead of us. But I do want to go into the details because you asked a great question. So I want to show the actual breakdown of it. This was the numbers we went up against, which was at the time 4,200. So we did 5,700 when we submitted. And then immediately after it, 2 weeks later, NetApp did a 12 node with 6,200 nodes. So they're ahead of us. But I do want to note one thing. The benchmark that we actually downloaded had a standard build that had a limit of 6,000. We didn't know it could go past 6,000, so we know better now. That's #1. You can notice overall response time. Again, this is 3x better in terms of the latency numbers for WekaIO. Really important number here is the number of clients. On the builds that they had done in November, it was 48 clients to run their build. To get 50% increase in their number, they required 50% more clients. So what that shows is there is no performance improvement per client. They cannot improve the number without more clients, right? With 19 clients, we got almost the same number. So you can see that on a per client basis, which is basically how efficiently are we using your server, we are 3 times more efficient than them. This becomes obvious again. We're getting 300 builds per client versus 86. These are the real important numbers because this is the efficiency of the very importantly expensive infrastructure.
I got news for you.
Yeah.
Customers are going to be far more interested in that next line.
This one?
Yes.
So Chris Meller made a great point. He said, it's a 2-horse race. Well, I argue it's a 1-horse race, but our horse is in the stable right now eating. But anyway, so on the cost per client basis, that was a real point. He said, there's no numbers here. So we have taken the spec numbers. You have to publicly show everything that's in your system. We have publicly available numbers. We actually took those numbers and said, they're the list price, so let's discount by 50% because that's what the street gets used of. These are the real numbers. So WekaIO versus it, you're paying 3 times as much for, slightly more build at a lot less efficient on your client bases. And then the ultimate truth of the matter is, this is a 12-node build. They can go to 24 nodes on the scale-out system. Because ultimately, this is really not a scale-out distributed file system. It is a scale-up system with clustering in front. So come 24 nodes, which is the maximum they can go to, it's really over. Our limitation on the design is 64,000 nodes. We've actually shown customers scaling to 1,000 nodes inside of AWS, no problem. So ultimately, we believe that this is a great story, and we look forward to our next submission.
Barbara, why do you focus on clients?
Because if you look at the actual spend inside of an IT environment, about 60% is spent on the actual compute infrastructure, and about 40%, these are the numbers we hear, and it's more like about 40% on storage. So your usage on clients, I mean, your users care about how much time can I get on the compute environment, and how fast can I get my job done. That's why I focus on that, because ultimately, if you have very efficient usage of your clients, you don't have to buy as many, or you get a lot more work done with the ones you have.
So you're considering the client being a host server, is that?
Yes,
okay.
Exactly. So yes, this is where you're running your cadence builds. This is where you're doing all the workload. And at the end of the day, you get to the machine learning as an example. All they care about is running more epoch. And if they can run twice as many or 4 times as many, their models get better, everything gets better. You take chips, the simulation times on chips now is over 50% of the entire cycle time of building a chip is actually just running simulations. If you can even save a month off that, it has a huge impact in terms of your environment. And I have a friend that works in the chip industry, and what they have to do is go to their IT director and say, I need more clients. I need to be able to run on more clients. So they're constantly looking for more utilization out of those. What we're doing is delivering that for them. This is the IBM Spectrum scale versus DDN versus WekaIO. So this is your classic parallel file system environment, where really it's only the parallel file systems compare. And they've done a thing called the 10-node challenge. And again, in their world, 10 nodes is 10 server clients that are running your application, whatever it could be. It could be a weather simulation or whatever. So they say, how efficiently can you feed these 10 servers with data? And you can see that WekaIO came in #1 ahead, I add, of the world's largest supercompute national laboratory summit, which is a 40 racks of IBM Spectrum scale, feeding in the same 10 nodes as we were feeding with a very small cluster in our lab. This was actually run on I think it was 4 or 6 supermicros in our lab. So that's another example of our bodacious claim. Last but not least, I actually want to finish with a customer. It's a company called Trey Altamira. They're running in the public Amazon cloud. They had a problem where their on-premises compute resources were so limited, they couldn't actually finish jobs in time for the contracts they had. And what they're doing is geospatial modeling and looking at Earth surface distortion when they have challenges around things like fracking or oil wells. If you listen to this video, which I encourage you to do, you'll hear them say that they reduced their workload from 2 weeks to do a run down to 2 days. That's a massive improvement in their ability to be able to actually service customers.
Trey Altamira is the world leader in measuring the ground and structural movements using satellite radar data. The measurements that we provide are used widely in such markets as oil and gas, mining, geohazard, and civil engineering. We exploit the images acquired by the radar to analyze the movements on the areas of interest for our customers. What's unique about our operating environment is that our software implements a processing chain of more than 100 steps, some of which are made of thousands of parallel jobs that need to access the input data and the results of the previous steps at the same time. For this reason, each analysis requires a significant processing power and a high-performance storage. Given the importance of these factors, we were looking for a solution that fulfill at least our 3 main requirements. The first one was about compatibility. The solution had to be compatible with our Linux reference distribution, that is Linux Ubuntu. The second evaluation criteria was about performance. It had to be faster than our on-premises solution and at least comparable with the last performance in cloud. That is the first solution that we tried on AWS. And finally, the last evaluation criteria was about stability. It had to be a stable solution. We looked at WekaIO and their matrix file system after an AWS solution architect recommended it as a possible alternative to Lustre file system on cloud. Concerning the stability, we spent many weeks in testing the Weka solution using workloads much heavier than we have ever tested on our on-premises environment or with the Lustre file system on cloud. The benefits that we got from this solution are many. First of all, we completely removed any production capacity limit. For example, a wide nation analysis would have taken more than 2 weeks and all our on-premises resources. Now, with WekaIO and AWS on-demand resources, we can complete that same analysis in less than 2 days. The WekaIO storage solution has had a significant impact on our business. New products and new services are now available. For example, we are the first in the world to offer a wide nation analysis as a standard commercial product. And we already won some contracts thanks to this new solution.